Hello and welcome to my channel called Math is Hard. Today's video will be about dual simplex method. Let's assume example minimum from 2x1 plus x2 with these conditions. All the variables are greater than 0. First, you can notice that our conditions are inequalities. We would like to have an equality, so we add a temporary variables. Let us rewrite the minimalization problem with temporary variables s1, s2, and s3. Here is greater than or equal, so we subtract variable s1. Same in the second condition. In the third condition is less than or equal, so we add variable s3. x1 is x2, and temporary variables s1, s2 and s3 must be greater than or equal to 0. Now we rewrite this example in table. First row will be the objective function. Let's rewrite the objective function in following form, and now we will place the equations in the table. So we write x1, x2, s1, s2, s3, and right-hand side. Now we will rewrite the equations in table beginning with objective function. x1 is minus 2, x2 is minus 1, and s1, s2, and s3 are zeros. The right-hand side is equal to 0. Same we do in other equations. x1 is 3, x2 is 1, s1 is minus 1, s2 and s3 are 0 and RHS is 3. Next equation x1 is 4, s2 is 3, s2 is minus 1 and RHS is 6. And in the last one we have 1, 2, 0, 0, 1, and 3. Now we want to have identity matrix here, so we multiply the whole first and second row by minus 1 to get identity matrix. We rewrite the table. If we multiply row minus 1, we get minus 3, minus 1, 1, 0, 0, minus 3. And in the third row minus 4, minus 3, 0, 1, 0, and minus 6. The last row will remain the same. Now we will find the most negative value from RHS. It is minus 6, so we mark the whole row. We consider only negative values, and for them we count the ratio of the first row and the third in absolute value. We consider these numbers. In absolute value, minus 2 divided by minus 4 and minus 1 divided by minus 3. And we get 1/3 and 1/2. 1/3 is less than 1/2. So we mark minus 3. It means that x2 will be basic and s2 will no longer be basic. We add x2 to base, so we want here 1 and 0 here. We divide the enter row by -3. Now rewrite the table. First row will be the same. Second row will be the same. Third row we divide by -3 and get 4/3. 1, 0, -1/3, 0, and 2. Last row will be the same. Okay, so now we had here 1 and we want 0 here. We add the third row to the second row and we get 0 here. We add the third row to the first row and we get 0 here. And we multiply third row by -2 and add to the fourth row. (4/3 plus -2 is -2/3. Then we get 0, 0, -1/3, 0, and 2. The same we do in second row. Third row will remain the same. We add -2 multiples of the third row to the last row. Okay, we have x2 in base and s2 out of the base. And now we will repeat out algorithm. We will find the most negative value from RHS. At s-1, we have there twice -1. It doesn't matter which one we choose, we will reach the same result in both cases. I choose for example the second row and mark the whole row. We consider only negative values and for them we count the ratio of the first row and the third in absolute value. We consider these numbers. In absolute value -2/3 divided by -5/3 and -1/3 divided by -1/3. It is 1 and 2/5. 2/5 is less than 1. So we mark -5/3. That means that x1 will be basic and s1 will no longer be basic. We add x1 to base, so we want here 1. We multiply the second row by -3/5. We rewrite the table. First row will remain the same. Second row is multiplied by -3/5. Third row will be the same. And last row will be the same. Now we will add the variables. x1, x2, s1, s2, s3, and right-hand side. We have 1 here and now we want to have here zeros. We multiply second row by 2/3 and add to the first row. And we will get 0 here. We multiply second row by -4/3 and add to the third row. And we multiply second row by 5/3 and add to the last row. Now we rewrite the table one more time and do the calculation. We don't have a negative value in right-hand side, so our algorithm ends. Optimal value for x1 is 3/5. Optimal value for x2 is 6/5. Thank you for watching. If you like the video, please like and subscribe.